We are AirLink from Letova School in Russia, Moscow. We are passionate about solving environmental challenges through innovative technology, and today we are excited to present our blue ocean idea, IoT fully autonomous station. Currently, environmental monitoring relies on expensive stationary stations that cannot track pollution distribution across large areas. Moscow, for example, has only 52 fixed stations, but air quality parameters change dramatically just kilometers away. Scientists cannot build accurate pollution distribution maps without dense sensor networks. Communities near industrial zones lack data about their air quality. Remote areas remain completely unmonitored despite being critical for climate research.
Our prototype is a fully autonomous environmental monitoring station. It measures CO2 concentration, temperature, humidity, and atmospheric pressure with precise geolocation and time synchronization. The system is built on an ESP32 platform and uses a Centurion SCD40 CO2 sensor, ensuring high measurement accuracy. Data is transmitted once every 10 minutes with IoT module, allowing a long-range communication with extremely low power consumption. Power comes from a solar panel with integrated battery, enabling true 24/7 autonomous operation. Thanks to its weather-resistant 3D printed enclosure, the device can operate in remote and hard-to-access areas, forming high-resolution spatial CO2 maps, something stationary urban monitoring stations simply cannot do. The environmental monitoring market is dominated by expensive stationary stations and complex industrial systems. They rely on fixed infrastructure, require constant maintenance, and provide data only for a few isolated locations. Competition is high, costs are high, and scalability is limited. A network of low-cost, fully autonomous IoT monitoring stations that work without grid power, without Wi-Fi, and without human involvement. These stations can be deployed anywhere, forming real-time, high-resolution environmental maps. We make environmental monitoring scalable, accessible, and truly distributed.
So now let's take a look at our eliminate, raise, reduce, and create matrix. First of all, what we eliminate is a requirement for manual charging, also for manual data extraction and configuration, along with frequent sensor servicing by providing an almost fully autonomous device. What we raise is the ease of its usage from unboxing to continuous operation, and also we raise durability in harsh and remote outdoor conditions by using a secure completion and also purchase simplicity. What we reduce is technical expertise required to interpret raw data because we use a convenient scale and also dependence on local power sources and human intervention. So what we create is a fully autonomous solar-powered environmental node which has a self-managing intelligent monitoring and also is a simple way for businesses to measure environmental impact.
We divided the roadmap for our product into 4 main stages. The first stage is already completed. We have gained a first customer, Zemlяков Crop Protection. After that, we need to apply for documentation to enter the US market and reach out to different companies. After that, we're going to enter the US market via partnerships. When that is completed, we're going to expand our sales through online marketplaces and business-to-government tenders. Also, we are planning to offer leasing to companies. The main costs of our project are the cost of the components and marketing. So the unit cost of our project is $373, so we're planning to sell it at $474. This will make us able to obtain a $80 margin and see payback after 15.5 months. We have observed 3 scenarios, the optimistic, pessimistic, and the normal scenario, where the price either stays the same, rises 20%, or falls 10% in the second year. However, we will still remain in profit. The existing market focuses mainly on productivity of use, which is providing high quality data. We also offer that, but we also offer a lot of other things, like simplicity and convenience of use, as our device is fully autonomous. Moreover, the maintenance is very simple, as it is nearly unneeded. The process of purchasing is also focused on simplicity, as people from our team will guide the company from purchase to installment.
The industry today captures air quality and CO2 monitoring dominated by sparse fixed stations and expensive industrial systems. Tier 1 customers capture industrial and public sector teams already reporting emissions who want more coverage than fixed stations can provide. Tier 2 non-customers are mid-sized plants, construction sites, farms, and logistics hubs that avoid monitoring due to cost, power, and maintenance complexity. Tier 3 non-customers are smart city and campus operators, researchers, and insurers who could use hyperlocal air data but don't think of IoT networks yet.
So to conclude, our station creates an affordable solar-powered environmental monitoring system that tracks CO2, temperature, humidity, and pressure, then transmits data via NB-IoT cellular networks. Our solution enables anyone from industrial companies to research institutions to build dense sensor networks without expensive infrastructure or manual data collection. Autonomous environmental sensing networks for data-driven sustainable future.